What's up, everybody? Welcome to Flux Harmonic. I'm David Wilson, and we're back again with another live stream for the I'm not gonna say August today. I'm gonna say Autumn Lisp Game Jam 2023, which is ending on Monday. And today is the last time I'll be streaming for this game jam because I'm kind of out of time, basically. Like 6 a.m. is the submission deadline tomorrow morning, and that's maybe, I don't know, like 12 p.m. 11 a.m. for me. Not exactly sure what time it is, but basically time's up. So what we're gonna get done today is basically the remaining work that we can probably get done on the logic of the game for the game jam this time. I'll do a little bit more polish up tomorrow just to get some basic details for how to play and everything on the screen so that someone could pull it up and play it if they wanted to. But we still need to make the game actually work in an end-to-end way. We spent some time on that yesterday, got a little bit hung up on moving like substacks of the piles to different to other piles. But we did get that working, got selections showing up for the cards that are currently selected, which is nice. So at least all that stuff feels pretty good now. But today we need to implement an algorithm that will enable us to check if there are any other valid moves left. And if there are no other valid moves left, then the player loses and they have to start a new game. Yesterday, I was talking sort of just high level about a couple ideas that I had for how to accomplish that. And I've been thinking a bit more about it this morning. I started sketching out a little bit of code and ideas about it this morning, but I haven't really written much yet. So we will be writing it together starting in just a few minutes. And if somehow we manage to get it done, at least at a basic level to where it works, or at least we feel pretty confident that it works, then we might be able to move on to some other polished duties. But at least for now, I think that we will focus mainly on the lose state checking, because that's really the last important thing that needs to be done to make sure that this is a game and not just a little exercise in implementing solitaire logic. So I'd like to say hello to the folks who've shown up so far. Benoit, Glenn, and Wakame Nad. Thank you all for being here. Appreciate it. Let's see. Let me check on my... Okay. It's looking good so far. Anything else worth noting? Not really. I mean, I haven't really done too much other than what we saw yesterday. So my thoughts so far on using Guile Hoot, which I've mentioned it every stream, I think, up until now. Guile Hoot is a new tool chain for compiling Scheme to WebAssembly so that you can do real Scheme code in the browser, including things like tail recursion, continuations, and also fully host managed garbage collection, which helps a lot with performance, because if you have a custom garbage collector written in WebAssembly for your language, then you have to do a lot of other manual memory management, and it might be slower than it would be if you just let the host, which is V8, or the Chromium engine, let its own garbage collector take care of things. So it's an interesting tool chain in that it does take advantage of these new bleeding edge WebAssembly features, and as such, it is pretty early on in its lifespan, but it does work. In fact, it's been working extremely well for me so far. I haven't run into any like real strange blocking issues, mainly just things that aren't there yet, which are currently being implemented. Like, let's say, being able to call out the JavaScript functions in the host, or things like a random number generator function, maybe some other convenient stuff here and there, but the core of Scheme is all working just fine, and we've been able to make quite a lot of progress on the logic side of things in Scheme. A lot of the other stuff, like drawing the screen, handling input, at least at a basic level, are all done in JavaScript. But I think, we've got enough written in Scheme that I feel pretty confident that, I can say that this is a game that was written in Scheme, at least in some part. Right now, there's about 410 lines of code in Scheme, and in JavaScript, there is 605, but, like I said, there's a lot of wiring that has to take place. And also the rendering code does take up a lot of space just because there's a lot of, calculations going on in there as well. But yes, as far as Hoot is concerned, I'm still like very optimistic about its future. I'm going to be using it for all future game jams from now on because it gives me the ability to write full Scheme code in the browser. And as more features get added, more of the library gets fleshed out, and the foreign function interface to JavaScript gets added, then all of the game can be written in Scheme, and then I can start building my own tools on top of it, which is going to be a lot of fun. Right now, I'm only using the HTML5 canvas for rendering, which is not ideal. It's worked really well for this particular game, but for high performance rendering, it's better to use OpenGL or WebGL. And I'm looking forward to being able to wire up some bindings to that side of the equation as the Hoot tool chain progresses a bit more. Okay, so let's take a look at what we did yesterday for those who may not have seen it, not in this tab, in this one. So this is the way the game looks so far. If I haven't mentioned it again on the stream so far, we're working on a Klondike Solitaire game, but with more of like a cyberpunk aesthetic. That's why the colors are so weird and the symbols are different. In the future, as I continue to work on this game after the jam is done, more things will be added to make it more obvious that this is sort of like a cyberpunk style game or like a hacker focused game, hacker themed game. But for now, this is as far as we've gotten as far as the theme is concerned. But you can select cards, like for instance, if I want to move this 7 onto the 8 over here, I use keyboard keys for that. The columns all have home row keys assigned, so A, S, D, F for the first 4 columns, then J, K, L, semicolon, no, sorry, J, K, L, the final 3. Semicolon removes the selection, so if I press F, you can see that the 7 is selected. If I press semicolon, it clears the selection. I press FS to move that 7 over to the 8. So it's a fully keyboard-controlled solitaire game. There's no clicking right now. Maybe later I would add something like that, but at least for now, you know, you just use your keyboard to control it. And I think that's pretty fun. I can press LU to move that ace up to the foundations. These keys are U, I, O, P up on these 4. And then to flip the card over on the stock, press G, because it's in between the 2 home row keys that we have for the columns down here. And then to select this heart, you would press H. You would press H to select this card that's on the top of the flipped over cards, I guess you would call it. So that's it for now. I'm pretty happy with what we've been able to accomplish in a week. I probably spent only, I would say no more than about 15 hours on this altogether, which is, you know, not a lot of time, I think, to have gotten this far. So not too bad. I'm pretty happy with it. I wish I could have gotten farther, but that's okay. Uh-oh. I saw the stream spin for 1 second. I hope that it's doing okay now. I don't know if it's a problem with my computer or a problem with Restream. I don't want to blame Restream too hastily because it could be my computer. Just check it on which tab could be the one that is... oh, you know what? I should close this. And I should close this too. All right. Apparently I had a couple other windows open that were chewing CPU, so hopefully that helps resolve some of the pressure at the moment. All right, we'll see how it goes. Okay, so let's get into the logic programming aspect that I mentioned before. So back in main.scm, in fact, let me turn down the music slightly because it's a bit loud on my end. There we go. So here's what I'm thinking. I'm coming up with a solution for checking win-lose state that doesn't require me to loop through the entire board and try to digest everything every time. Hey Judy, nice to see you. So basically, if you were to do this the sort of brute force way, or the way that enables you to just like loop through everything, just do it a very naive way every time, basically what you would do is you would look at every card that is possible to be moved, and then you would see, then you would look at every other location on the board where a card could be moved to, and see if this card could be moved to one of those positions. So for instance, let's see if there's one that fits the bill right now. Yeah, so you would look, let's say we look at the Jack of Hearts here. You loop over all the other top of stack positions and see if that Jack of Hearts could go on top of any of these. And in this case, the answer is no. However, this 10 of spades could go on top of the Jack, but we wouldn't get to that until later. Since you can move substacks onto other stacks, you would have to check all of the cards as a starting point and see where they could possibly be moved, because then you would want to hit this 9 right here, this 9 of hearts, and see that it can be moved to the 10 of spades. You also have to check all the cards that are either whatever card is visible here on the top of this stack, or what is remaining in the stack of cards that is yet to be flipped over, because there may be cards in there that could be played down here. It's just you haven't gotten to them yet from flipping the cards over. So to do it the naive way, you would just run that whole scan every time the player moved a card. And I mean, it's possible that you could do that as an approach, but it just feels kind of slow to me. So I'm trying to think of a slightly more efficient way to do it. And the thought that I have in mind is that what you need to know are which cards could possibly be moved. You don't necessarily have to know where they could be moved. You just have to know that they can be moved. And that doesn't mean that it's at the top of a stack. It means that we've seen that there is a place where it can be moved. That's one table of information, the set of cards that can be moved. If you have that, then it makes it very easy to check whether the player has won or lost, because you can just see if that list is empty or not. And if it's not empty, then you keep going. Hey, Dave. The second thing that you need is a table for all of the cards where some other card can be moved to it. And I think that you need these two tables because you need to be able to dynamically update this information every time a card gets moved. So whenever you move this 9 to this 10, you need to update the state for not only the 10 here, now this 10 can't be moved up to a foundation. So that removes any possible places it could be going up in the foundation stacks. But also any of these cards here, like this 9 is now on the 10. It could still be moved elsewhere. The king can still be moved elsewhere. The 8 can still be moved elsewhere. So those things may not really change unless this card was a possible choice for one of these cards. But then this card that's under the stack that you moved also now needs to be reevaluated for where it could be moved to, because maybe now it could be moved up to a foundation. So there's some extra bookkeeping that needs to be done. For the sake of time, maybe we should just do the naive approach completely first. Just because doing the caching approach may take longer. We'll do not brute force. We'll do the full rescan approach every time. We'll get that working first because we still need to implement it anyway. Like at the very beginning, you're gonna have to rescan all the cards and check them before you can do a sort of dynamic updating approach. So we have to write that logic anyway. So let's just use that, and then anytime a card gets moved, we'll just rescan the whole thing. See how slow it is. Maybe it's not that slow after all because there's not that many cards. But you are doing kind of like a almost n squared algorithm, looking at each card and looping over a subset of the rest of them every time. So yeah, let's just get started doing that. Shouldn't take too long because I've already started the implementation. And then if we have time, we could try to do a more dynamic approach to update what we have. So where I started with this was adding a function, two functions. One is called check valid moves and one is called check valid locations. So check valid moves is looking for any card that could potentially be moved somewhere else and seeing what locations to which it could be moved. So that means checking to see if it could be moved to another pile or potentially moved to one of the foundation stacks. Check valid locations is the function that for a given card, based on the information about the card, whether it's like a 10 of spades, let's say, whether a card of 10 of spades, regardless of where it is, whether it could be moved to another location. So this one calculates the list of locations where the card could go. This one calculates which cards can be moved in general. So they both work together to build this table of information. In reality, we don't necessarily need this second function if we're not caching and updating a cache. We just need this first function to just loop through and find whether there's locations. So I guess we need this one to do the real check, but anyway. We'll work through that and see where we can get to it. So I've added a couple more state variables. One is movable cards, which is a list of cards that could possibly be moved. And that's two pieces of information. One is the rank and suit of the card, and the other is the current location of the card, so that we can sort of do some calculations on that, whether it's in a pile or in the foundation or in the stock, which is like the cards that have yet to be flipped over. So in this check valid moves, I'm clearing out this movable cards list because I want to repopulate it, at least in the initial scan. And then I start by looping over all of the piles. So looping over each of these piles here. This is a vector, so I'm going to use a normal loop to loop over that because I don't want to use vector for each, because vector for each turns the vector into a list first, which is like an additional loop over that. Not really worth doing that, so let's just loop over it using a normal let loop. And then we know that we only have 7 piles, so we're just going to check for that. If we've hit 7, we return the list of movable cards, which may not be necessary, but we're going to do it anyway. And then this is the actual substantive bit of the logic of this function. So since we have multiple offsets for some of these piles, like for instance, this pile has 0, 1, 2 for offsets because there's 3 cards in the stack. We have the offset information in addition to the index. That is how you identify a location for a pile card. We loop over all of the cards in the pile. Now this one here, I'm calling set movable cards. I haven't actually tested this code yet, so I don't know whether it works. Benoit says, any plans for an Easter egg in the game? I hadn't thought about it yet, but I'm certainly open to any creative suggestions that you have. All right, so to set the new value of movable cards, what I would do is check for valid locations and then append the result of that to movable cards, but that doesn't seem right to me. We would only do this if check valid locations return true. So when, all right, so when check valid locations card, and we're calling make selection here, Contra code shows up a list of links to all the streams and names of the attendees. That would be cool. I definitely wanted to put like a credit screen in on the game to acknowledge all the people who were on the streams and, you know, gave feedback and suggestions and stuff like that. So that is something I want to do for this, but we'll see if I have time for it. So when check valid locations, we call make selection. I think I'm going to change this whole selection concept to location because it really just defines a location for a card. So pile index offset, and then if there are valid locations for it, then we will append the card to, we'll const the card onto movable cards, so that makes it easy. And that should give us a list of cards that are movable from the piles, but that's one place. We also need to loop through to the next pile in the vector, so index +1 vector ref piles index. Now that doesn't seem right to me. I was writing this code while I was at my daughter's basketball practice this morning, and I was kind of like half paying attention to the code and half paying attention to the practice, so some of the things I've done here are not very smart. Let me think about this for a second. So if I do this, I'm gonna end up reaching for something, because I should actually be doing +1, but if I do that, I'm gonna reach outside of the range of the vector. So I can't do it at that point. Where am I calling into the vector? Yeah, I haven't done it inside. It's almost like I need to do a let here. Which I'm not really crazy about. Because, you know, I don't like dropping lets in. Ooh, wait, hold on. Let's collapse these two. Apparently I already have a let here, so that's cool. Anyway, I don't like dropping a bunch of lets in because lets eventually get turned into lambdas, or I don't know, maybe Guile will compile all that out so it doesn't turn into a lambda necessarily, but I don't want to have like a bunch of unneeded function calls to digest all these lets. That's also why I tend to avoid using let star, because you've got like nested lets all over the place, which means possibly multiple nested lambda calls that are happening. But a good compiler can probably shake all that out. All right, so let offset O. Hey, Jason, nice to see you. Yes, working while attending the kids' activities. I just did the same yesterday. Yeah, I mean, that's kind of how it goes. Just carry your laptop along and pay attention to anything that's happening. All right, so yeah, we're just incrementing index. All right. So that all looks fine for now. We'll see whether that ends up being wrong. So we have this loop here, but we also have another peer loop that's looking at the stock cards. So the stock cards are the ones that are in this stack, but also this is another stack here. So there's actually two stacks. So whenever you flip one card over here, you're popping it off this stack and pushing it onto this stack. So I have to check both of those together, I think. Now, what I can do is append the stock to the drawn stock. I think that's what I called it, drawn stock. Yeah. David says the let star should be compiled to a simple sequence of continuations. I guess it depends on whether a continuation is basically like a function, right? Maybe it's lower level than a function call, but still kind of like a function. It feels more heavy than just a series of assignments. Okay, so we've appended those two lists together, which is cool. We have an index, which we don't need because stock doesn't really have an index, but do we need to? No, hold on now. So we're checking the stock cards. Maybe we can just do a for each on this and not have to do all the extra goop. So how about that? For each. Oh, and one thing I missed here. I gave it a lambda. Ah, okay. Here's one way we can get rid of this. The for each needs a list as a parameter. Dave says it doesn't result in a closure if that's what you're wondering. It's the same as a series of assignments. That's cool. I need to look into the code for the Guile compiler a bit more. Because I've written my own scheme compiler and it doesn't have any optimizations. So I'm sort of going based on my own experience of what a scheme compiler would do under the covers. So I haven't seen like sophisticated compiler optimization code yet to know what to really expect. All right, so we got the for each. This needs to be a lambda here. And this stock to check whole expression can get dropped down to be the peer of the lambda in the for each. Let's call this inside same way. No. Okay. Also, when we're checking valid moves, we're not checking any of the cards that are here in the foundation because you don't want to suggest or imply that a card up here could be moved out of the foundation stack, even though it is possible for one to be moved out. Because the cards are supposed to be flowing towards the foundations and not away from it. So we wouldn't consider those valid moves to move them out. However, a player could do that and unblock themselves in the game, which, you know, I've played thousands of Solitaire, or I've played Solitaire from the GNOME. I've played GNOME Solitaire thousands of times, and I have some strategies in mind that I want to make possible, but you don't necessarily need to encourage them. Okay. For each lambda card, why is this lambda? Lambda, duh. There we go. Now that's why the indentation is not working. Cool. So check valid locations when check valid locations, same logic as we saw before. Inside this when, we want to do the same thing. Set movable cards, const card, movable cards. So this needs to be fleshed out a little bit. We also need to store the selection information. So I probably do need a let here. Stock index, that also doesn't really make a whole lot of sense. And I also want to, so we're consting the card onto movable cards, but I do want to const the location onto that. So card itself is a const. We're consting a const onto a list, so it should be fine. And then we're consting that onto movable cards. So we're pushing on top of the list of movable cards. Same thing up here. Here, we can say location. Do the same thing with this location. And same in this position as well. Const card, location, movable cards. All right. So now, this seems okay. I don't know yet whether it's going to work the way I hope it works. But we'll try it out. The next thing we need to do is check valid locations. So now that we know that we have a card, source location, is that what I meant to say there? Yeah, source location. So this will check all of the tops of all the piles. It will also check the tops of the foundation stack. So it's not that many checks that have to be made, because given a particular card, we only have to look at a place where it can be placed, and it can't be placed inside of a stack. It can only be placed on top of a stack, so it's a much cheaper check to make. So similarly, we'll be looping through everything. Now, without caching this information, we can be a bit simpler. We don't have to hold a lot of information, so I can just loop through these things more simply. Still need to do a loop like this over the piles, but I don't have to loop over all of the offsets, so we can cut this down a bit. So I could start with movable false. Well, let's see. Maybe we should assume that it's movable until we find that it's not. We'll see whether it actually shakes out like that in the end. All right, so we loop over each index of the pile vector. And then we only look at the top card. So I think we can call find card, but maybe that's too much. How about this? I guess it could be this. I mean, why is Lispy not working right? I can't move S expressions anymore. I don't know why. We'll use a let star now, since Dave made me feel better about that. All right, so find card location. Now, find card, yeah, okay, selection, cool. So that will find the card at that location, because we don't know what it is yet. Offset is always going to be 0 in this case. Now, for that card, we also need a function to check whether it's a valid move. And I was writing this up here as well. Valid pile card, valid foundation card. So we had some logic for that already up in move card, right up here. And let's see, if and card color, source card, desk card, card rank. I think all this stuff can go. Then we can drop. Did I paste that yet? Let's paste that here before I go too far. There we go. I can also get rid of this if and just let it be the and directly. we'll take a closer look at that in a minute. Maybe I'll put this back as an if, and then the else case, I gotta put that print back out so we have all that information in the output. Now, yeah, I think that's good. So we say moving to pile, and then we check whether the pile move is valid. Source card, desk card, let pop cards, source. All right. So that's good. We can use that to start with. So now valid pile moves, source card, desk card. So we're looking at making sure that the card color is not equal, and the card rank of the source card should be 1 less than the destination card. There's another possibility, which is that the desk card is false, which would mean that the stack is empty. And we do need to check that because the king can be moved to an empty stack. So I need to add that check here. I haven't actually run into that case yet. So let's see. So not equal card color, desk card. So card rank. How are we checking the rank of king in this case? I wonder how we're doing that. It's probably care to rank. Okay, so K is 13. Cool. Where was I? Here. So equal card rank 13. And the all right. That should do it. Okay, I think that's it, right? So valid pile move. Define valid. Now, there's not a desk card here, is there? Maybe a desk location? Let's take a look at the code we have up here. So moving to foundation, we did a find card on desk card before. Looks like the chat overlay is picking up YouTube messages again. I logged into Streamlabs right before the stream, and apparently it fixed it, whatever was going on there. Maybe an out of a token that needed to be refreshed or something. All right. So I'm trying to think of maximum reusability here. Valid foundation move. I don't want to have to call find card on the foundation because we're going to be doing two. Well, maybe it's fine. Let's go with it to start with, and then we'll think about it. I'm gonna take this whole little thing here. I'm gonna use an if when valid foundation move source card desk card. Okay. So when it's valid, we do the whole logic, and then when it's not valid, we just write out something about that. Then I'll just plop this logic down here. And then we'll review it really quickly and make sure that it's copacetic. So if the card rank is 1, which is ace, and the, null? How was I checking that before? That doesn't make sense. Clearly it worked though. Selection, preview selection. I wonder if find card, am I returning an empty list? Car foundation. So for foundation, I'm returning the empty list. Otherwise, I'm returning a card. That doesn't seem right. I should be returning a false, I think, on that. So let's just make this be a direct value ref. So and equivalent card rank 1 and desk card is and not desk card. Otherwise, the desk card is a pair, and the suits are equal, and the rank, I don't know why I'm using equiv versus equal. Card rank, yeah, cool. So that does make sense. So valid pile move, valid foundation move. Now we have both these functions, which we can refer to inside of the check valid locations function. So the first one is checking piles. We're looking at a card and a source location. We're looping. Then inside the let, we construct the location based on the current pile index. We find the card. Then here we would call if valid pile move card. Maybe should I say source card here just to be consistent, to make it obvious? Okay. Source card to we'll call that dest card too. Okay. So if it's a valid pile move, then I guess we could just return true, period, right? Maybe we don't need this outside thing. Later, we do need to keep track of all the locations. Maybe let's just assume we're going to continue looking. Check valid locations. Yeah, let's do that. We'll keep track of it. So not movable. Valid locations is going to be an empty list. And then the location, I guess we will const onto the list of valid locations, which is misspelled. We also need to do that. But we still need to continue looping. So if it's not a valid move, we don't do anything. We just skip it. We keep looping until we reach the end. Okay, so that does it for the piles. Now for the foundations, we gotta do the same thing. So let loop index 0. We're gonna loop over another vector in this case, if equal index 4. How about this? Okay, and let's take this movable out. Whoops. Now we can straighten up this win a little bit. All right. Inside this win, we're going to do a similar thing. Let star. There's some, similarities here. So I don't know if we can abstract some of this. Dest card, find card, location, because it's almost exactly the same. Yeah, you know what? I'm just looking over two vectors. I'm looking at the top of the card on each of them. So, I think that's what I can do, right? For each. Still need to let map last. Okay, can I do something like that? Maybe a fold? Map last with a filter, Benoit says. This could be a fold-like situation. Lambda. It's foundation string. Okay, the second is the accumulator. Where were we? We're right up here, I think. All right, so fold lambda target. Maybe this is not entirely necessary, but hey, let's just see if it works. Okay, so we've got the beginning of the lambda here. What we want for this is a const of the symbol and the vector. Yes, that's right. Fold is a reduction. We're accumulating the piles that could work. Yep. So const foundation, foundations. Yeah, we're just basically saying we have these two target locations or target sources. Target sources doesn't sound right. And this logic here basically just gets dropped in. Okay, so what we'll do is see target vec is footer of target details. And then this is going to be the target type. Maybe that's not even necessary, to be honest. Probably don't need the outer. Let loop. Where was I even reffing? Something's wrong. Oh. I don't need the vector. Well, I need the vector only for the length. So it seems a little overkill. Okay, vector length. It's a little bit weird. But that's okay. And this whole thing here can just get deleted, I think. All right, so if we have the target count, footer, target details, this could even just go right here because it's not used again. Okay. And we need a list. And at the end, whenever we've reached the count, then we append, let's see, valid locations. Well, I mean, we're kind of screwing with this locally scoped variable here, but that's okay. in this scope. So in fact, I could probably just return. Kind of defeats the purpose of fold, right? No, that's fine. I mean, it works. Oof. Hold on. Okay. So if the index is less than count, then do the loop. And if we find a valid location, we just set the valid locations list, which is a local variable, effectively. And then when we hit the end of the vector, we return valid locations, which is the locally edited version of valid locations that was passed in. So when that comes back out, that's the new accumulation of values. So that should work. So just one fold. Source card. And when we check valid moves, we're looking at cards for, oh, you know what? We need to do one thing. We can't check. All right. This is why you shouldn't overgeneralize. I don't want to check the foundation when the source card is not at offset 0. I suppose I could just not add it to this list in that case. Feels a little bit weird though. This is gonna look really ugly. Just to let you know. If source card, sorry, what is it? Source location. So selection. Target and selection offset. If that is a pile and all right, if the offset is 0, then we're going to add this to the const, which will create a list ultimately. Otherwise, we just put an empty list in there. So that should take care of that. We won't add that to the list of things to be checked. Hey, Alejandro. You missed a little bit. I guess it's almost been an hour by now. Still working on this. Let's see, storing valid locations. Okay, so we've got most of that done. So that should be the logic. Now, let's write this out. Begin, PK, because I like to yell at myself when I'm coding. It's great. Movable cards, and then we're going to return movable cards. Now we will recompile this code. And we'll just see what happens. Oh, I haven't actually called it yet. 203, I've screwed up a let somewhere. Yeah, I didn't wrap the let around the code that's supposed to be inside. Makes sense. This is check valid moves. I want to do that at the very beginning when we set the game state. So not get game state, get pile state, new game. This is after we've done everything. Check valid moves. All right. Let's move this up a little bit too, because Move card now uses this logic. Great. And also we want to call that again after move card. Anytime move card gets called, we should check valid moves and to do used cache. So now after every move, wow, what happened? 110. Wrong number of arguments to equal. Yeah, you're right. Card rank source card. There you go. Then 178, selection offset, selection. 201, movable card. Okay, yeah. Movable cards. Cool. Try that again. Possibly unbound selection. Where? Must be in the code that I just added. Selection. Make selection. Selection. All right, so there's selection. Yeah, probably not selection. It's source location. Also offset, somehow I got that busted. Is it probably right there, huh? No, not in that one. Interesting. So the loop has offset bound here, so that's not the problem. Maybe it's this one? Find card, offset. No, not that one either. Not that one. Oh, right here. Needs to be a let star. Okay. Looks like we're good now. Let's pull up the dev console, refresh. Let's see, car, wrong type argument in position 1. So this is pretty early on in the code. It must be before we start checking valid moves. So PK. And we'll just take a little look at that one. Okay, about to check, makes sense. Calling car somewhere and there's an unspecified result, which probably means one of the other functions I'm calling is returning unspecified when I don't intend for it to. So check valid moves. Can't be that one. Check valid locations. I'm not using the result of that one for anything. It could be. So I'm consing this together. I'm assuming this means, well, it shouldn't be triggering that yet, should I? All right, let's take a little look. Let's see if we even make it this far. Yes, it would be nice if I had a REPL. Okay, so we are in this function. Cooter target details. Wait a second. This is wrong. Anything else with car in here? Just see how far we get. Okay, so we are looping. Index what? Cooter is throwing now. Okay, uncaught exception, codor, wrong type argument in position 1, expecting pair. Index is less than count. So codor target details. Well, let's check out target details. Maybe it's something I'm doing with that little logic that I put in. Target details, foundation. Shouldn't be foundation by itself. Maybe that's what it is. Okay, that makes sense. How did I do that? Foundation. Vector link foundations. This should have come up right. We're constantly. Oh, you know what? This should be a list. Yeah, that's got to be it. List of consts, because we're trying to const this thing onto the front of whatever comes after. So that must be it. I think we made it a little bit farther this time. Yeah, target details, foundation, index. Now we've got a new problem here. Car, wrong argument type in position 1. And this is after we hit index 1 for foundations. Car, target details. We know that target details has foundation, so that should be fine. Maybe it didn't find a dest card. So that does make sense. Valid pile move, source card, dest card. So let's check valid pile move. Let's see. I think this logic might need to be changed, because we don't want to hit this path at all if dest card is false. I guess I should just add another case here. Let's just do that. It must be what the problem is on that branch. Okay, cool. So let's see what it tells us. We're getting a cheat code to the game now. Just take all of these loaded image prints. I don't see anything written out about the valid moves. Wow. My typing ability is just phenomenal today. Argument out of range. Check index 7. If equal index 7, then I should be able to print out movable cards. Let's just take a look at it at any point. All right, this seems like it's telling me all of the movable cards, but it feels like this is too many. I can't imagine this many cards are actually movable. So there must be something wrong. All right, so next is an uncaught exception, out of range vector ref. Okay, so we're looking for if equal index 7. Oh, did I do this same stupid thing? No. see if we make it that far. It must be crashing randomly, unless I just fixed the bug somehow. Would that be anything to do with the fact that the cards are all visible? No, don't think so. Get image. Why am I printing that out? Get image. Yeah, let's not do that. This thing, I don't know why I'm printing that out. 204, let's just get rid of some noise here. All right, so all the loaded image lines, I want those gone also. Okay, now we've got a better grasp at this. So we can visually spot check this and see if it's right. Stock 00, that says there's a 2 of spades that can be moved somewhere. Yeah. That's a lie, because it can't be moved. Yeah, where's that 2 gonna go? I don't see anywhere for that. 7 of hearts. Yeah, 7 of hearts in the stock. Sure, the 7 of hearts could get moved. It could get moved to an 8. Is it literally just telling me every single card that I'm just not putting this in right? Let's see. Okay, there's a queen in the stock that it didn't talk about. Wait, 4 of diamonds. Okay, I think it is giving me every single card in the stock. There's a diamond of 2. There's a queen of diamonds, 3 of clubs. Yeah, so I'm adding everything apparently. So check valid moves. When check valid locations, card locations, set movable cards. So it's returning true every time. I must have done something really dumb here. Ah. Okay. I think what I need to do is check when it's a pair. Because if it's null, an empty list does not... it's not a falsy value in Scheme. It's considered a truthy value. So that could have tripped up the code a little bit. Now, how many cards we have showing up from stock? Still a bunch of stock cards showing up. And for the piles, let's see. S4, 4 of spades. Where is there a 4 of spades? Oh, right there, probably. It's still doing something wrong. Yeah, it's a lot of stuff being written out here. Let's take all those index prints. All right. Oh, weird. Hold on a second. I did not use those predicates at all. I didn't use a foundation one. Okay, that's another thing that needs to be parameterized here. Okay, I think that maybe this was not the smartest idea in the world. Because this function is not valid for foundation cards. This is really gross. That's okay. We're just trying to get it working. Code can be pretty later. So this is going to be a cadder and valid move is going to be cadder target details. So this is going to be valid move now. Okay, so make selection, card target details, index 0, desk card, find location, find card location, valid move, source card, desk card, set valid locations, const location, valid location. So valid move needs to return true only whenever it's relevant. Let's reload. Still seems like it's returning a lot of cards, which doesn't seem right. How can I effectively debug this? Whoops. Okay, and let's roll it again. Interesting. I don't see it say anything about valid loc. Did it say it right there? No. So what is it? Oh. Didn't recompile. How long has it been since I recompiled, huh? Okay, let's check that now. All right, valid loc pile 10 procedure. Okay, that's right. Target details. Let's get rid of that now because that's not needed. All right, so there's valid loc. It's empty. There's one that seems right. So there's a few things that are showing up that look right. And by the end of the loop, or the end of the function, let's say, maybe I can write out, let's do this, when. And then the begin, we'll drop it after the let to print out the valid locations that were encountered. Oh wait, that's not in the right spot, is it? No, it's fine. It just isn't indented correctly. Cool. Okay, so we're looking for a movable. I don't know what this list is. Valid loc. Wasn't in that one. It was in. Oh, it is in this one, is it? Valid loc. I need to return it. No, I don't. Yes, I do. Valid locations. Okay. Maybe I was doing something wrong here before. Is that possible? No, I think that was right. Okay, maybe I made a mistake by changing that. Because ultimately this loop will return the valid locations at the end. Because at the end of the let, at the end of the loop, the if will return this valid locations. So let me just recompile that and just check the output. Interesting that valid loc is saying empty list. Also, it's really weird that valid loc is a bunch of empty lists, but it's somehow getting aggregated in an unexpected way, because this fold is supposed to be taking the result of every call to the function and passing it back in as a second parameter. So if there was ever a valid location, it should be getting accumulated. I don't know how, at the very end, we end up with this longer list. Oh, this is because I'm returning something wrong somewhere. So check valid locations. In theory, it should return an empty list at the end. So check valid locations. Oh, wait a second, hold on. This is probably the problem here, one of them. Doing the same check in more than one place. That seems more reasonable. So let's see, stock 7 of hearts can be moved to the 8. No, to the 8 of clubs. Let's see, a 4 of clubs can be moved to the 5 of diamonds. The 4 of spades could be moved to the 5 of diamonds. The 7 of spades can be moved to the 8. 6 of spades could be moved to the 7. Ace of diamonds can be moved to the foundation. 7 of clubs can be moved to the 8 of diamonds. So this all looks right. I think these are correct. So then if I go and move one card to another, let's see how the state gets updated. So if I move the 7 here to the 8, now we've got an updated movable list. And what I want to do is check real quick. Oh, we got a whole bunch of spam output now, so I'm going to lose the original. Let's just copy these and put them side by side. And a scratch buffer. Take a little look. So that's the before. Indent. It didn't do it, did it? I wish you would actually indent it for me. Let's not go through that whole rigmarole right now. Did I copy this one or the other one? 4. Oh wow, did it actually not keep the output? I think that's it, isn't it? So the first was this. There's a 7 of hearts. Yeah, oh, okay. That makes sense because, well, it might make sense. Can you not indent to multiple lines? Nothing can help me. Okay, I'm just trying to like compare them side by side and see which ones are different. And I really don't want to have to go through and put all these in separate lines. But, you know, it'll only take a minute, so let's just quickly do it. So how's your day going? Mine is fine, except for all the manual labor here. I'm curious how different these are gonna look. They shouldn't look that different. So I see S4, S7, S6. Those three are the same. D1, C7, C1, C10, D9, H9, H1, D7. Okay, so I see D7 is gone. There's an S1 that's in both. There's a C6. Okay, so S10, C6, those are in both. S1, I think D7 might be one that's different in both. H1, H9, D9, C10, C1, C7, D1, S6. So C4, S4, S7. There's a couple that are different. The heart and the stock is gone. Let's see. Yeah, heart, because that yellow 8 or the black 8 is gone, so that heart is no longer valid. There's also a 7 of diamonds. Maybe that's this one. Now there's a C4. That's a 4 of clubs that's valid, which probably goes onto this 5, which we move the card off that, which makes sense now. And the ace of spades, which is somehow... Where is the ace of spades? Okay, that's not right. Pile 2, 0. So that would be this pile, but the ace is not valid. I don't know how I came up with that. Unless it's because it can go to a foundation. So if I go undo all the deletes. Okay, so the ace of spades is always there. So that ace of spades check is bad. Is there a member function macro available? Yeah, I think so. Okay, so that ace of spades should not have shown up there. So what did we do wrong? Oh. Let me check the output again. Pile 2, 0. Yeah, so the ace of spades is not at 0. And it never was. So something is incorrect in this logic. I think we're getting closer though. Like, it feels like it's sort of working. We'll take this line out now. Some of this other stuff, valid, loc could also be deleted because I don't want to have all the extra output spam. Target details we'll take out also. So the ace of spades, did I get this wrong? If the source location is a pile and the offset is 0, then add it in, otherwise add in an empty list. So that should be right. And that's for the source location. And then down in, yeah, the offset's being passed in. Oh, here it is. I can't be holding on to that because the location needs to be updated for every call because the offset is changing for... Wait, hold on. What did I do here? Yeah, this needs to be updated every loop. So that can't be done there. Whoops, what did I just do? Okay. That's unfortunate. We need location twice, so we'll do a let location here. So that should solve that problem. Do I do the same thing here incorrectly? No, I don't need to do that. Okay, so I think that that will solve this issue that we saw. Location. Where is location? I think that was the problem. All right. Cool. So let's try moving another card, maybe. I don't want to go through that whole thing again. I guess the question is, what is the best way to validate what's happening? One thing that I had thought about was highlighting the cards that are movable. But that might be too time consuming. Oh, you know what? I actually got the whole game locked to the same initial deck, so it's easier to test things. So we can test this now. Is S1 in the list? No, I don't see S1 anywhere. S4, S7, S6. Oh no, S1 is here. That can't be right. That it cannot be right. How is it possible? Index, pile, offset. Offset is here. Offset is being incremented every loop step. So hold on. I don't increment offset. Not smart. Okay, so at the end, no matter what happens, I should increment offset for each step through the for each. Okay. I think it's gone now. S4, S7, S6, H9, D7, C6, S10. Okay, I think that there's maybe a couple cards that have been removed now, which is good. This seems like a more reasonable list of possibilities. So if I were to start cutting through this, let's see, I'll move the... Why is it redoing the state every time? F, D... What else? We got this ace down at the end that can go to a foundation. Let's rotate the stack. There's a heart, 2 of hearts I can't really do anything with right now. Queen can't do anything. 4, I can put the 4 on the last stack. Ooh. Okay, so that was a crash. What happened there? Valid move from pile to pile, uncaught exception. Value failed to match. Where? So it lost the card somehow when that happened. Value failed to match. What does it even mean? Valid move from pile to pile unspecified. So valid move. Huh. Let's reload. I'm curious about what just happened. So FD. I wasn't moving from pile to pile. That's a good point. I think that the code, I think the output, maybe misleading. So valid pile move. Does it look at the source at all? No, it only looks at the card color. It doesn't look where it came from. So I think that this could be a stock also. So pile or stock. Because we're only looking at the destination target here, so the source could be stock. So that may be misleading. Actually, it could be very misleading because you can also move a card from a foundation to a pile. All right, so if it's valid, move to pile. Am I using a match anywhere in here? I'm not using a match. But I wonder if if cond is boiling down to that. Let's check prelude. Value failed to match. Simple match 1. What do you want to bet that's being used in cond somewhere, or case? Simple match pattern. Syntax case. No. Weird. I'm not using this. Must be somewhere else. All right. Interesting. What I'm guessing though is that I'm using a case somewhere, and the value that's getting passed into the case is unspecified because it's coming from a bug somewhere else. So I was trying to move a stock down to a pile, the very last pile, and the move was a 4 of diamonds onto a 5 of spades, which is a valid move. So it knows that it's a 4 of diamonds to a 5 of spades. So let's just sort of trace the logic there. The problem would be in probably pop card or push card. Let's take a look at those two functions. Selection, target, selection. So the stock. We're pushing card onto the pile. We're taking a card from stock. But maybe the selection is null? That can't be right because we just saw it. Valid move from pile to pile. Okay. Valid move to pile, popped card. Oh, popped cards. Is unspecified? That's not good. Popped cards. Okay, that's what happened. Got it. So I changed the pile case of pop card to return popped cards for pile, but I did not do that for the other cases, so foundation or stock. So now they're not returning a list. It's returning unspecified. So what should I do here? Let popped cards. There's only going to be one. We're setting the vector, vector ref foundations. Pop-Tarts. You're making me hungry. Is the car of this vector ref. And then we're going to return list of popped card. This is a little bit nasty looking here. No breakfast yet? Yeah, it's breakfast time. At least for you. For me, it's gonna be dinner time pretty soon. Okay. So this is gonna be car for drawn stock. And we're gonna go here and say list popped card. Boom. Okay. Now, thankfully, we can reproduce the exact same situation because I've got the deck locked. So F, D, L, U, G, 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 H, L. There we go. So the 5 moved, sorry, the 4 moved onto the 5. Cool, so we can continue now. Let's see, we got any other interesting moves that we could do? There's a 6 up here that I can move on to the 7. Fried eggs over chili beans, that sounds good. All right, so L, 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 L over to S. Okay, I can move that 7 to the 8. We can move this jack over to the queen. Whoops. All right, so that one crashed also. That'll be harder to get back to. Checking loc, uncaught, exception, valid move to pile. That is a jack of hearts being moved. That is the list of popped cards. Checking loc. Where does that get called? Checking loc. I think that what happened... Oh, you know what? I think it's because this pile is now empty. Yes, so I'm calling car on an empty pile list, and that's in the checking function. So check valid moves. So how am I getting to a car on one of these? Location, make selection. Check valid locations, card location. So if there's nothing there, I should just skip this whole path. Vector ref piles index. This returns a list. That would have been fine, I think. Because the 4 each won't do anything on an empty list. Would it? Moving to last pile. No, I think what happened is because this pile is now going to be empty, is calling car on... Okay, it's happening in this function, so it must be something here. So for each... Card target details, desk card, find card, location. Maybe find card is doing it. Pile, loop pile, vector F piles, car for sure. It's in this bit of code for sure. So if it's empty, I think I'm already doing a check for foundation. So I have the pile. We're looping. Okay, I think this may be it. So if index is less than offset, otherwise car pile. Now this needs to be Peter says, similar to me, I would not do anything on an empty stomach. Yes, that's for sure. Hey, Peter. All right. We're almost there. I mean, I think it's almost working correctly, the naive approach. And in fact, it seems like it's kind of fast enough. It hasn't seemed that slow. So maybe I don't even need to have a more elaborate solution unless I wanted to provide hints on locations where the user could move. I have all the information. I could probably just store it and use it and refresh it every time anyway. So I'm debating on how I want to add the null check in here. I guess I could do it here. If null pile, then return false. Otherwise, do the... Well, I still need a loop, right? So it can't be there. If index is less than offset? Oh, okay. No, that's right. That's right. I'm pretty sure. So what had I done before? Yeah, Alejandro says modify the condition with an and. Well, I can do an and around the if, I think. So and pair pile. But yeah, if I do an and, it just lets it go through if it's true here, and then it would return the value that comes out of this. So I think that should be sufficient. So yeah, we're gonna have to replicate this again. I don't know exactly what moves I had made the last time, but I guess the goal is just to get to an empty pile. So that jack needs to move is basically the solution here. So FD, whoa, FD. We're gonna move the ace to a foundation pile. We're gonna go through the list here and find the 4. We're gonna move, oh, I missed it. Well, actually, let's do this. We're gonna move this to the foundation pile. Hey, that's not working. Invalid move from pile to foundation. Okay, I don't think we've checked this this one yet. We need to be able to move from the stock to a foundation. Invalid move from pile to foundation. Valid foundation move. Oh, you know what? I think this is backwards. If the card rank yeah, I think this needs to be like that. And this needs to be normal. Yep. This might change our logic a little bit too, or the result of the checks. All right, let's go back again. F, D, H. Oh, I need to do the LU again. Alejandro says, I think this code needs more macros to verify these cases. Maybe, but I'm reluctant to go that far. All right, so the 4 I can move down. So if I press HL, okay. Let's press G again. The 2, let's move the 2 from H to U. That worked, cool. What was the other stuff that I did? I think I moved a... Let's see. There was a queen I had opened. All right, so let's do this one. J, J, J to D. No, that's not right, is it? Let's move the F, F to J. Which one was it? Was it 7? Okay, the 7 here. L, 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 L. Move that one to D. And then let's try moving the jack over on the left side to the right side. Okay, now it's working. The king. Let's see if I can move this king over on this side, because I haven't tried that yet. So move that over here. Boom, that worked. Great. So now F, I. I can't see the cards that are down below here, unfortunately. This 4 can move over on this stack. So if I press L, 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 A, all right. I'm definitely going to get myself into a position soon where I can't do anything. Whoops. Let's rotate the cards. There's a 3. Actually, can I read the stack information here? There's a ace of spades. There's a 4 of diamonds at the bottom of... What is this dot, dot, dot here? Oh, they're empty. That's why. Okay, that makes sense. There's a 4 of diamonds at the bottom of this. There's also a 5 of spades. And a 6 of diamonds. 6 of spades, 7 of spades. That's a pretty tall stack right now. Kind of going blindly. Peter says, is there not a sneaky way to save the complete state before waiting for next input to easily harvest states before an issue occurs? Maybe. I mean, that's what I'm doing. I mean, well, yeah, the idea was I would sort of have a cached view of all possible moves and sort of update that, just sort of do it like a diff effectively and not have to recalculate it every time, but I don't think we're gonna have time to finish that because we're almost out of time as it is. All right, so 8, 10, Jack, 5, the king. I haven't moved a king from the stack down to a pile yet, but that works. Cool, all right. The 5 can't go anywhere yet. 9, 3, 4. The 4 can go on top of this 5, so I can press H, K. Yep. This 3 can go on top of the 2. H, nope. H, U. 4. I think there's a 5 somewhere. No. King can go down, so if I move the king down to... No. Oh, I made a mistake. I shouldn't have pressed that. Yeah, I can't actually see the board now because I need to monitor the state. And unfortunately, for whatever reason, the canvas doesn't resize whenever I resize the view. Like I tried a few different things to make that work and it never actually did what I wanted it to. So it doesn't ever re-render, which is really unfortunate because I can't like, you know, scroll this up and down and keep an eye on things. So now I basically have to restart the game because I don't have a way to deal with that. In fact, it's going to be a problem no matter what because I can't see the whole screen. Let's just give it another shot and see how far we can get because we got about 15 minutes left. But I'm feeling pretty confident now that a lot of the logic is working because we saw it, you know, doing pretty well. So, all right, FD. Let's play it like a real game now. I'm gonna try some different moves this time. No. Yeah, the developer tools in separate window. That's actually a really good idea. That's a really good idea. Can I do that? I think I can pop it out. Well, I can at least put it on a side monitor. Yeah, pop out, right? Boom, great. Thank you, Alejandro. That's a great idea. Okay, so let's clear the selection. And I'm trying to move the, what was it? The 10 to the jack, so. Wait, what? Okay, yeah. All right, so we're gonna move that over here. Let's see, 7, queen. There's a 6 here I can move. There's a 9 I can put on top of that 10 if I go, okay. It's kind of intuitive using the keyboard keys in the end. I can move this jack. Oh, okay. I'll move that to J. I'll move this ace up to O. What else can we do? The 7 over here, not that one. We can move it to this column. It's getting a little bit long now, though. I probably should start trimming that down. Okay, so now we're gonna grab this 2 and put it. Hello. Wow, took a few presses for that to show up on the selection. Kind of weird. Okay, so we're gonna put that over on O, I think. All right. Queen, can't use it yet. 4, we can put it on the 5. So I'll select that, put it over here. Then draw a card. We can put this card over. Oops. Okay, I missed that one now. I don't have an undo yet. I do need one of those soon. 3 can go on top of the 4. And then the 2, we don't have the ace of clubs yet. I'm not going to put that down on the 3 just yet. We don't need to make that stack any taller. 5, king can come down. The jack, not yet. 9, 3, not yet. 9. All right, the 4 can definitely go down. I'm gonna put it on the diamond, I think, because the heart might be usable soon. Let me double check if there's anything I can move around in this. Oh, you know what? There's a 3 on top of the ace. Guess that's fine though. Yeah, okay, that must have been there for a legitimate reason. 3 of diamonds. Yeah, I can put that down. So I'll put it down on the first stack. 4 of hearts. We have a 3 of hearts. Let me get that up there actually. So the second stack, I'll put that on O. The 4 can go on O. The 5 can go on O. So now we're clearing some things out. All right, so we gotta. Okay, we're doing all right so far. Let's. The king can come down. 6. Yeah, the 6 could go over. I'm reluctant to use it yet. 7 could go over. The 2 can certainly go over to. Oh no. Oh, I. Okay. I really need some key hints on the screen to make it easier to understand what's going on. Queen can come down. 2 can go across. A of clubs. Do I have one around? Oh, you know what? Why did I not do that? That should have been the first thing I did when all that showed up. Okay, cool. So we got that up. The 2 can come over. So let's select that. Go over to you. Queen can come down again. The 10 can come down. So select that and go to J. Okay. The 2 can go. I think we're getting pretty close here. Let's go with the 3 of diamonds up to you. The 2 of clubs will go over to P. 10 jack. Let's move the jack down onto the queen. Five. Okay, I think we can move the 3 up to the P. We can move the 4 up to the P. We can move the 5 up to the P. All right, we're making some progress here. I think we could actually win this one. I don't know if it will work. It'd be nice if we could win a game before the end of the stream. If I had to replicate it, I would not be able to. So, let's see, what else we got here? There's a 4 of spades over here. We don't need that yet. This 8 could go on the 9, but I don't need to do that yet. If I had a 6, there's a 6 here. I can move this. Okay, I should do that. So let's break up this stack a little bit. Put this 10 over on F. Then I can take the 6. I can take the 7. It's unfortunate that the 2 8s are both here. Okay, so the jack can go down here, and felt like there was something I could do with that. Okay, let's keep moving. The 9 can go on the 10, so let's put that down on J. 3 can go. 6. Move the 8 to the 9. Yes. So let me put that. Thank you, Alejandro. Let me put that over. Well, actually, let's wait on that one because I might be able to. How can I get to that? I need a 4 of spades, which is up here. I'm starting to wonder if the initial card placement is wrong. But we'll have to investigate that in a second. 7. Is there a 6? The 6 is not reachable right now. We might end up with a situation soon where we can't finish the game. Let's see. Let's move the 8 down to the 9. 10 to the jack. The 9 can come down. I'm trying to see where these things are going to go. Uh-oh. Just knowing where Benoit is. I guess it's getting close to time for that, right? Let's try to whittle this down. I think I can do that. Grab the 6 and put it over on the 7. The 7 here can go on to an 8. I'll put it onto the this 8. Six. Okay, we can use a 6. We can put it over on O. I think the 9 can come down now, so we'll bring that down to D. The 7 can go over to the pile. There's an 8. I can move that 7 here. So the stack is empty now, which is cool with the stock, and it hasn't crashed, which is a good sign. We're going to move that over to F. The 8 can go up to O. Let's see. Where are we going? Where are we going? We need a 4. Oh, yeah. I wanted this 4 here. Can I get to it? Yes. Alejandro is correct. All the piles, the cards that are higher should be turned over at first. I forgot all about that. That's entirely correct. That is true. That's so funny. Man, I didn't consider that at all in the design. Huh. Okay, let's get back to it anyway. I'm trying to see what I can do here. I want to get to that 4, but I don't think I have a way to move it. Now it's an improved game? Yeah, I don't know. It's definitely got its own character at the moment. 5. Yeah, I might be stuck. In fact, let's see what the readout is telling me. If there are any moves. It says you win. No. That's wrong. I invented a new solitaire mode? Maybe. It tells me there's still some that are movable. But you know what? What it considers movable could be incorrect. Just because you can move between 2 piles doesn't mean that you should. So maybe pile to pile moves are not valid. I don't know. I got to think about that a little bit. So it's telling me that 13 of spade, which is a king. Why would a spade of 13 be movable? Pile 4-4? Oh, yeah, I can move it from here to here. But that is not a move that will help. Okay, so that kind of move should not be included in the... All right. Alejandro says you should only put kings over the table, empty pile. Yeah, but that shouldn't be considered part of the... I need to put some to-do items here. Because that just doesn't make any sense at all. Queen, yes. Well, maybe. Maybe, Peter. Let's go back over here for a second. All right, let me just take one last look at this. Regardless of what the game is telling me, well, let's see what some of the other suggestions it has. So there's another king here it wants to move. There's a jack it wants to move. Sure, I can move this jack. Let's see what happens whenever I move the jack over to the queen. That's fine. It still tells me I win. I don't win. There's a 6 of diamonds somewhere that it thinks can be moved. Right here to there. Yeah, sure. Doesn't help me though. It's gonna tell me to move things back and forth probably. So if I move the 6 to, what is it? Yeah, I can't even see it. So empty is 14. No, empty doesn't show up. So now what is the suggestion? 13, 13, 13. That's 3 kings that can be moved. Sure, they can be moved. An 8 of diamonds somewhere. 8 of diamonds is here. Can you move to a 9? Sure, that could be moved. Doesn't mean that it should. I can move this king though. You know what? A king that is not at the topmost offset could be valid, because that is something that could expose a card that could be played. So valid move unless all right, so that is something worth noting. Now the board seems a bit more balanced. Can we get to anything? The queen, there's another king. Okay, so we've got this 8. Okay, we got it right there. Let's get this 8 over to that 9. Then the queen over on the side can come over to A. I think we're gonna win this game. Now I just need a button to just automatically solve the rest. I'm gonna take one of the 8s and put it on the 9. I don't know if that was a mistake. Actually, let's take the 7 and put it on this other 8 so that this 8 can go into the pile up at the top. This 9 can go into the pile up at the top. There's a 9 and a 10 that can go up there. Let's see, we got a 5. Where's the 6? Okay, we got this 5 that can go up. We got the 6 that can go up. 6, 7, 7, 8, 9, 10. There's the 8 here, 9, 10. The 10, yeah, we got this, man. Yes, we need a solve all. Maybe if you press enter, it would do the rest of it. I'm curious to see what will happen whenever I clear all these cards, though. There's got to be some kind of edge case that's going to crop up. All right, so that is hearts to go to O. So the clubs goes to P, the jack goes to U, queen goes to U. The jack of spades goes to I, queen of spades, I. We got the, let's see, queen of hearts goes to O. And the king goes to I. And then we've got the last 2 here. And that goes to U. Now, what does it tell me? No movable cards, you win. All right. So, cool. Right at the end of the stream, we were actually able to successfully win a game. Now, it doesn't tell me that I won, except for in the console. And it's been telling me for like the last 20 moves that I win. I think I must be doing an OR check somewhere as soon as the stock got cleared out entirely, it said I won, which is wrong, obviously. But at the end, the check does show that there is no remaining movable cards. And also there's, I think that the other check would see that everything is empty. So at least we have a game that functions. I was able to do all the moves that I wanted to do. Alejandro definitely pointed out that there is a problem with how things are represented. But that's okay. I mean, those are all small things that can be fixed. In fact, I could probably just fix the card face thing tomorrow. And what else? Just the one or two little issues here and there, I think, were something that should be fixed. But yeah, I think I was able to cheat just because of the way that all the cards were facing up. So that wasn't cool. But anyway, I'm pretty happy with the progress in the game. I mean, it works. So it was a winnable position for a long time. I mean, it could have been winnable, but it shouldn't tell me that I won. So tomorrow I won't be here either, unfortunately, because the competition ends at 6 a.m. 6 a.m. Eastern Time, US. Right now it's 10 a.m., so 4 hours before now, which for me would be noon. So I won't be able to stream that early. I can stream anytime I want to continue working on the game, not in the context of the game jam, but I think my wife would probably not like that too much. But yes, you know, I'll keep posting progress on the game as I work on it to Mastodon or Fediverse. So if you're following me there, which I think many of you are, then you'll see that. But yeah, I'm going to continue working on the game and make it into a fully fledged thing because I think it's going to be a lot of fun. And Benoit says maybe that's a contra code. Maybe. But probably I'll end up submitting the game in a less than stellar state just because it's going to take a bit more work to get all the rest of the polish in. That's okay, though. I'm fine with that. And there's other game jams that allow you to continue working on an existing game. So if there's one in December that would let me do that, I might continue working on the same game then. And by then, the new version of Hoot should be out, which might have foreign function interface to JavaScript. So I might be able to take out all the existing JavaScript code and rewrite it all in Scheme, and then have everything in Scheme, which would be great. All right, well, you know, I think that's probably the most successful game jam I've had yet on streams. So that's cool. I'm happy with that. It made it better that I'm not using my own language that's like half broken half the time. So, yes, get rid of JS. I will get rid of it as soon as I can. Dave's working to make that happen. I see it happening in the repo. Okay, folks, thank you all so much for being a part of this whole jam this week. I really appreciate all of you hanging around with me and watching me do this. And next time, we'll do it again, whenever that is. Probably December sometime. We'll see. So I hope you all have a great rest of your weekend. Until next time, keep it creative. We'll see you.